All right. Hello, hello. We are going to go through the work and machines section 14.2. Yesterday your job was to listen to the Ed puzzle on efficiency. This talks about how machines make work easier, and then just discuss the difference between work in and work out. All right, so machines are anything that make work easier. And again, work is force or distance. So machines can make work easier by increasing the size of the force. So the force that you put in is increased by the machine, increase the distance over which the force works, or change the direction. You often want to change direction so that we can work with gravity to make an object move against gravity, such as a pulley. If you think about a pulley lifting up a deer into a tree to hang it there. All right, so we just need to distinguish between work in and work out. Work in is what you are doing, and work out is what the machine does. So both are still multiplying force and distance. You just have to figure out what your force is, and the distance you moved are going to be the work input. So the formula is force in times distance in. Output is what the machine is doing. So it's the same force times distance, only it's the force of the machine, or the force out, times the distance out. So the distance that the machine moves. Due to the fact that we need friction in order for machines to work properly, work output is always less because energy is lost to friction. All right, so our mechanical advantage is a multiplier. It is the amount of times the machine multiplies the force in. And most of our mechanical advantages will be over 1. A mechanical advantage of 1 just simply means that you are just changing direction. An actual mechanical advantage is going to be the work that's actually done, then work that's actually, or the forces that are in and out. And so that includes friction. And ideal is as if there is 0 friction and 100% efficiency. So this is a comparison of your distances. So the input is what the machine's doing, or what you do, and the output is what the machine is traveling. All right. So here we see a car on a ramp, and the woman drives the car a distance of 1.8 meters to raise the car up 0.3 meters. So ideal is assuming that it has 100% efficiency. So we always list our variables: distance in and distance out. In is what the car went, the lady drove. Out is what the ramp actually lifted the car. So we divide our input force by our input distance by distance out, and it's 1.8 divided by 0.3 is 6. All right, we are going to do some practice problems now.